So we're going to do a design. Now, I first have to issue a disclaimer. I am still in the process of learning the program we're going to use. The program we're going to use is one called KiCad. And if you just Google it, you'll find it. It's an open source program. The actual development is hosted in France, but SourceForge has a hub for it that includes a pretty good wiki on how to use it. KiCad itself is composed of several different programs, all brought together by a shell, and I'll show you that shortly. The program I'm most, KiCad is open source, meaning that of course you can download it free of charge, make revisions to it if you want to. KiCad is in desperate need of a good auto router. So if some of you are looking for a good project, for a graduation project, and you want to work in EDA, and you want to develop something having to deal with auto routing, you've got an audience that is very, very eager to hear what you might have to say. But this is not the program that I know best. I've really just been using it very, very briefly. I started learning it probably just a few weeks ago with any sort of seriousness. And the reason is that the program I used to use appears to be no longer developed. The program I used to use is a proprietary piece of software. It was very, very good, had a very awesome auto router, but it appears to be a closed project. So I'm now transferring all my work to KiCad, any work that I might do to KiCad. And so I'm in the process of learning it myself. So there may be a couple spots in this process where I do some stumbling. I hope you forgive me. All right, let's start a design. We'll close what we had. Starting KiCad, well, download, you know how to download things, you know how to install. It's available for Linux and Windows. There are official downloads for Linux and Windows. If you're a Linux user, you can get it from your Linux repositories in most distributions. If you're a Windows user, you can just download it directly from the site. There are some unofficial Mac versions as well, Mac builds. So if you're a OS X user, there are some unofficial builds you can use for doing that. This is what we call the KiCad shell. And what I'm going to do, this is basically the wrapper around all the different pieces that make up the KiCad suite. This is a button that will take you to the schematic editor called EE-Schema. This is the button that will take you to the tool that maps components or parts to footprints. This is the tool that you use for actually doing PC board layout. This is a tool for viewing your Gerbers, and this is a tool that I never use. One of the things about KiCad is the terminology that they use. What we've been calling a part and what most people call a part, they call a component. And what we call, and what most people call a footprint, KiCad calls a module or a footprint. So components are parts, modules are footprints. Components are the things you put into schematics. Modules are the things you use to represent the things in schematics on your PC board. So to start a new project, we just say new. And let's go here, create a folder called, I don't know, I'll just call it K4 because I can't think of anything else. So am I in my K folder? Yeah, try that. Creating a folder, go up here. Do I have my K folder? Yep, there it is. So I'm going to call this, I'll just call this buffer.pro. Now I've got a new project. Nothing in it. If we look, all we have in here is a text file that describes our project. Not much of a project yet. So we're going to start by doing the schematic. And I did that simply by clicking the eSchema button. There's our schematic capture. It'll issue you a warning. No, it's not a warning, it's just info. And it's just telling us that the file used to store a schematic for this project doesn't exist yet. It's just telling us this for our information. As soon as we save it, when we open it again, no problems. Now, one of the things about this, we're going to see how the user interface can be kind of what? If you're a toolbar-based user, you'll notice there's a toolbar up here. You'll notice there's also a toolbar here and a toolbar here. All three toolbars are critical to using both the schematic capture as well as the layout. If you are a menu user, this is the goofiest thing. These guys, they're not in the menu. Some of these guys may or may not be in the menu. I haven't verified that. So basically what I'm saying, and there may be some things in the menu that don't appear on the toolbar. So the interface really relies heavily on the toolbars, and is supplemented by the menu. So one of the first things you'll want to do is get your page settings. Here, this is my first revision, so I'll call it 0.1, hasn't been released yet. I'll call it my buffer, and I'll just use my name as the name of the company. You can set the size of the sheet if you want. One of the things it does is it automatically updates the title block. I'm going to zoom into this area. Zooming in and zooming out is very, very important. And the program gives you a few different ways to zoom in. F1 will zoom in. F2 will zoom out. Also use the mouse wheel. So you can use the mouse wheel to zoom in and zoom out. Right next to F1 and F2, there's F3, and that does a graphics redraw. Sometimes, since this is graphically intensive, the screen will get corrupted. You'll get stuff that just isn't supposed to be there, and you'll want to refresh the screen or redraw the screen using F3. Another important key is the home key. That will automatically zoom the entire design. Get to know F1, F2, F3, and home. Those are your friends when you're navigating the screen. So to zoom in, I can do F1, and you'll notice the zoom actually will center itself. Go back home. It'll center itself wherever you had the cursor. Some people think that's a great thing, an awesome thing. Some people are bothered by it. Zoom in, zoom out. And you'll notice here in my title bar, the program automatically reflected changes in my settings into the title bar, including the date. So it does a fair amount of the drudgery work for you. When I click Home, we'll get back to our main view. Let's add some parts to the schematic. To add parts, there's a button here. Place a component. You can click that. You can say Place Component, or you can just hit the A key. I will select the tool over here, click the button, and we get a browser. If you know the name of the component you're looking for, you can just type it, click OK. You probably don't know the name since you're beginning, so you'll want to select by browser. This brings up a list of libraries. Parts are put into libraries, components. Here are the parts in the ADC DAC. I just happen to know the part I want is in the linear. So you can actually browse what your parts look like. And so I happen to know the part I'm looking for is here. And it's an LM741. There it is. Once I've found the part I want, I can insert it into the schematic by clicking the Insert into Schematic button. And there it is. And I can move it around. I'm going to drop it right in the middle. I want to add another part. So I'm going to add a resistor. And I happen to know that the name is R. The name of resistor is R. If I didn't know that, I could browse for it here. Many of your basic kinds of parts are going to be in the library called device. So if we look in device, there's an inductor, FET, here we've got R. Click, and let's stick here. Let's do another one. Once you have it in the history list, you just select it and go. And another one. Okay, what I've got here is actually two of them. So I'm just going to undo. All right. So I've got two resistors moving. You can do it the long way. Right-click, select, move, and move. Or you can do it the short way, which is to mouse over the part you want to move and just type M, the M key. That'll get you to move the part. If there's some question about what you're selecting, for example, here I've got the cursor over this bit of text. This bit of text overlaps the actual component. When I right-click to select, it'll actually ask me, do I want to select the text or do I want to select the component? So a lot of times when you try to do something, it'll ask you for clarification. In this case, I want the component, and I can move the component. If you have a component already down, you can copy it, and there's your copy. No need to paste. Oftentimes, the orientation of the part isn't as you want. So you can change orientations using the Orient component menu, right contextual menu. And here you've got a number of options. You can rotate it. You can flip it around the y-axis and flip it around the x-axis and flip it around the y-axis. So rotating simply rotates the part. And I want to rotate that like so, and then I'm going to move it right up here. I'm going to move this guy right there. Mirroring, under Orient, mirror, or on the x-axis, flips it around the x-axis, or on the y-axis, flips it around the y-axis. All right, what I'm going to do, I'm going to make this a unity gain buffer. Unity gain buffer. Most of you people are digital people, so I'm doing this deliberately to irritate you by doing an analog design. All right, to actually make connections, that's done by the place a wire option over here, or place a wire. And once you do that, you just click. Oops. Didn't get it. And now we got it. Click. Click. Done. Click. I want a corner here. Done. Done. Click. Done. So we need power. We need ground. To insert grounds, you want to use this guy, PowerPort. PowerPort browser looks a lot like the component browser, but Power has a couple of peculiarities to it. This is a list of all the sorts of power, default kinds of power things that KiCad is aware of. You'll see 3.3 volts and a lot of things that you probably might use. We actually want a ground. I want a ground here. Second one here. And we'll add some more grounds later. Ground. Now I need some input and output connectors. Place a component. Connectors are in the con library, and I want con, this is the number of connectors. There's a 1 pin, 10 pin. For my input, I want 2. For my output, I want 2, and for power, I actually want 3. Power and input aren't oriented correctly, so I can flip these, or on the y-axis. That's done by doing orient y. Move that. Well, let's connect this to ground. You hear some of that stuff that sometimes comes up. If you hit F3, you'll clean up the display. And let's connect this here. Notice at the junction, it added a dot. I'll connect that there. So it's beginning to look like something. Here's my power input. I'll use this for power. I'm going to place a ground in the middle. There's my ground. Square that up. And what I'm going to do for power, I'm actually going to use named nets. So this is going to be my power going to pins 7 and 4. However, I don't want to draw snake a net down here. That's going to create a lot of visual clutter in my schematic and kind of interfere with some semantics, some more important semantics. So what I'm going to do instead, I'm going to put little stubs on these guys. And I'm going to use labels on the nets. So I'm going to give this guy a name. I'll just call it plus. And I've attached the name to that net. attach a name here. That's attached to that net. I'll attach a name to this net, calling it B+. So now these two automatically connect. And B-. Now this automatically connects there. Once I've done that, I can actually grab a block. Oops. Try just to grab. No. If I wanted to spend the time, I could just get this power stuff and put it up in the corner to get it out of the way, so we really just concentrate on the circuit itself. A couple more things left to do. You'll notice our parts don't have values. This is just R. A couple ways to assign values to parts in your schematic if you want to. Easiest way is probably to simply edit the entire part. And the easiest way to edit the component is to click E while you're hovering over it. When you edit the component, you'll just get a screen that has all sorts of information about the component, and you can set the value right here. So I'll make that 100K resistor. It's become 100K. I'm going to E this guy, set the value, make that 100K as well. 100K resistor. We'll make this guy 200. So now it's beginning to look like something. Got an input, output. It would be nice if this had a better name. We can also edit just the field value. So I could edit just the field value. Change that. Or I could edit the entire component and change the field value here. So I just find it easier to do the one thing. All right, almost there. Almost there. If you zoom in, we're going to see, good, we've got a value, but notice that R question mark. U question mark. Those question marks are supposed to be numbers. R1, R2, and so on. R3. Now we could, here in the reference field, type in R1, R2, R3, and so forth. Or we could do it automatically. And we do it automatically by using the annotate schematic. Annotating the schematic will automatically, got a bunch of options, will automatically number parts for us. So there we have it. It looks like we're done. Next thing we're going to do is a design check, an electric rules check. Looks like we're done. We do this. We run the test. Oh, we're not done. We've got some errors. Pin not connected, pin not connected. It gives us some, this is where it's located. Cool thing about this is that you will be given hints. It's saying that green arrow says that's where your problem is, that's where a problem is, that's where a problem is. Pin not connected, pin not connected, pin connected to some other pins but no pin to drive it. Well, pin not connected is easy. We've got pins and we haven't connected them. The schematic capture program wants to be sure that you meant to leave those disconnected rather than accidentally leaving those disconnected. So to say that, yes, I meant to leave those disconnected, you use the place a no contact flag. So bink, bink, save, run the design rule check again, and we still have one more problem. Pin connected to some other pins, but no pin to drive it. Now this can be a little bit confusing, and if we had more time, I would go into it. I will just give you the quick solution by saying that things like ground and power, they are considered driven sources. Driven sources. They're expecting to see some kind of output driving that net. And in our case here, we have nothing that's, quote, driving the ground. So the solution is we have to flag, using this guy, place new power port. We're going to give the schematic a flag that says, this is a power port, okay? Yes, I don't have anything driving my ground. I just want to let you know that's okay. So now I've marked this as a power, and when I run the DRC again, beautiful. So that's our schematic. Next thing to do, we have to export our netlist. So we're going to generate a netlist. It's going to ask us for a format. We'll take the default. And yes, I'll call it buffer.net. I export it. Bang. We've got a netlist. So we're done with the schematic.